Now we're going to discuss aqueous solutions. So, for example, we all know that table salt or sodium chloride dissolves in water. We have a sodium chloride solution. It does not contain any sodium chloride units that are still hooked together. So, whoops, sorry about that. When we have a sodium chloride solution, what we have are the sodium atoms and the chlorine atoms come apart and they interact with the solvent or the water molecules. So the water molecules actually pull those two ions apart, and we have the cations and the anions dispersed throughout the solution. So only dissolved sodium ions and chloride ions are present. So substances such as sodium chloride that completely dissociate into ions in solution are called strong electrolytes. That's where that term electrolytes come from. That's where the cations and the anions are dispersed throughout the solution. So, for example, let's think of what if we have a compound that is composed of not just monatomics but polyatomics. So for example, silver nitrate, Ag, we know that nitrate is one of the polyatomic ions, one of the common ones, AgNO3. So as a solid, it's a crystal structure. It has a formula unit of AgNO3, but when we put it into water, the silvers and the nitrates disperse out into the solution, and they interact with the water. They're soluble in the water. So there is no silver and nitrate. So when you stir it up, it dissolves and you don't see any solid in the bottom of the beaker. So they're independent ions. Okay. On the other hand, silver chloride is a substance that is insoluble in water. So, for example, if we have silver chloride, we say that it is insoluble because in water, and we're talking about water throughout this whole presentation. Sometimes you'll have solutions that are made of another solvent, but it's insoluble. So its crystal lattice stays together. And if we were to look at this in real life, we would see that we would have a solution with some solid in the bottom of the beaker. So if we have this apparatus where we have a light bulb and we want to complete a circuit, it has a battery to be able to light up this light bulb. An electrolytic solution, or a solution that has these positive and negative ions in it, can light up the light bulb. If you put the two electrodes down into the solution, it can carry charge. So this sodium chloride solution can carry charge. A pure water solution, which is pure distilled water with no ions in it, and the kind that comes out of our tap is not like this. The kind that comes out of our tap has ions in it, so it does conduct electricity. That's why if you're standing in a puddle of water and an electrical current gets in the water, you can get shocked, and that's dangerous. Notice that the light bulb for the pure water does not light up. This is called a strong electrolyte. This is not an electrolytic solution. Okay, now we have this looks pretty scary, but there are some solubility rules that you must know. So make yourself some flashcards, whatever you need to do to learn these solubility rules. It's really important. Now, some common ions, we have some common rules here that we can go by. Okay, let me get my pen so that I can highlight these. Okay, so compounds containing the following ions are mostly soluble. Okay, so if you have these in the compound, lithium, sodium, potassium, okay, those are the alkali metals in the first column of the periodic table. Ammonium ion, that one polyatomic that has a positive charge. Nitrate, acetate, that's not one that I told you had to learn last time, but now you need to know it. That's acetate ion that makes acetic acid. Chloride, bromide, iodide, so the halogens all. will always be soluble. So think about the halogen sodium chloride, soluble. Potassium bromide, soluble. Calcium bromide, soluble. Okay, sulfate ion is usually soluble. Some exceptions to these is if you have a compound with one of these things. So when any of these ions pair up with silver, this weird mercury ion, or lead, okay, then the compound is insoluble. When sulfate pairs with strontium, barium, lead, or calcium, so calcium sulfate, the compound is insoluble. This is something, unfortunately, that you just need to memorize. You need to learn this, okay? So mostly compounds of hydroxide and sulfide are insoluble. Mostly compounds of carbonate and phosphate are insoluble, except, of course, we're going to have some exceptions. We already said that lithium, sodium, potassium, and ammonium are always soluble. So those are exceptions. Sodium hydroxide, sodium sulfate, potassium hydroxide, potassium sulfide, ammonium sulfide, those are all soluble. When sulfide pairs with calcium, strontium, or barium, the compound is soluble. So calcium sulfide then, okay, that is going to be soluble. Strontium sulfide is soluble, not insoluble. These are exceptions. Barium sulfide is soluble. Whoops. And those are actually what we call slightly soluble. So these three here are slightly soluble. When either of these ions pair with lithium, sodium, potassium, or ammonium, the compound is soluble. So lithium phosphate, sodium phosphate, ammonium phosphate, ammonium carbonate, soluble. This is something that you need to memorize, so get busy working on that. Okay, for example, the solubilities indicate that the compounds containing the lithium ion are soluble. So usually if you see lithium ion, you should realize that it's going to be soluble. Okay, so it's going to be soluble. There's no chance that lithium is going to be insoluble. Compounds such as lithium bromide, lithium hydroxide, and lithium carbonate dissolve in water to form strong electrolytic solutions. The solubility rules state that compounds containing nitrate are soluble. So all compounds of nitrate are soluble. Silver nitrate is a real common compound that we use to get silver into solution to do chemical reactions with silver. Lead nitrate is soluble. Calcium nitrate is soluble. So these are the general rules of things that are most of the time going to be soluble. So here's a flow chart that might help you to know when things are going to be soluble and insoluble. Compounds that are mostly soluble. The halogens, yes, they're usually going to be soluble unless it's silver, mercury, or lead. Sulfates are usually going to be soluble unless it's strontium, barium, lead, or calcium. Okay, these are all going to be soluble. Lithium, sodium, potassium, ammonium, nitrate, and remember I told you you need to learn acetate. It wasn't on your list to learn last time, but you need to know what acetate is. Those will always be soluble if that ion is in the compound. Okay, so now let's talk about solubility rules and things that are mostly insoluble. Okay, so the solubility rules that state that with some exception, compounds containing carbonate are insoluble, but there are exceptions. Compounds such as calcium carbonate, iron carbonate, strontium carbonate, copper carbonate do not dissolve in water, and we're talking about water here. Note that the solubility rules contain some exceptions. For example, compounds with carbonate are soluble when paired with lithium, sodium, potassium, or ammonium. because we know that these are always soluble. So they are exceptions. Always exceptions. Always soluble. It takes you some practice and some time to memorize this. Thus, lithium carbonate, sodium carbonate, potassium carbonate, and ammonium carbonate are soluble. We have another flow chart for compounds that are mostly insoluble. Compounds that are mostly insoluble: hydroxide compounds, sulfide compounds, carbonate compounds, and phosphate compounds. But remember our exceptions, because we always are going to have our lithium, sodium, potassium, ammonium, calcium, strontium, barium. Those are always going to be, if it contains that, it's going to be soluble. If it doesn't, it's insoluble. Again, our lithium, sodium, potassium, and ammonium for hydroxide, those will be soluble. They will be insoluble unless it's calcium, strontium, or barium, and then it's what we call slightly soluble. Otherwise, it's insoluble. For carbonate and phosphate, we have, does the compound contain lithium, sodium, potassium, or ammonium? Because those are always soluble. If it doesn't, then it's insoluble. Okay, so for mostly insoluble, the solubility rules state that with some exceptions, compounds containing the carbonate ion are insoluble. Such compounds such as calcium carbonate, iron carbonate, strontium carbonate, copper carbonate do not dissolve in water. Note that the solubility rules have some exceptions. Okay, so compounds containing carbonate are soluble when paired with lithium, sodium, potassium, or ammonium. Lithium carbonate, sodium carbonate, potassium carbonate, and ammonium carbonate are soluble. Okay, so according to the rules for solubility that you must learn, barium carbonate will dissolve in water. So here we have barium. So what we're imagining here then is that we have our barium ions, and that would be these smaller ones, because usually cations are smaller. Okay, and we have our chloride ions in solution. They dissolve out, and they're out there in solution, ready. They're interacting with water molecules that are keeping it in solution, ready to do some chemistry. Okay, which of the following compounds is insoluble in water? Okay, so let's look at this. Would it be lithium sulfate? Look, we've got our lithium there. We've got our sulfate there. That has got to be soluble, right? Because it's got one of those that says it's always soluble. What about potassium hydroxide? We've got our potassium there. It's not an exception, so that's going to be soluble. We've got carbonate. Usually carbonates are insoluble, and it's with calcium, so it's not an exception. So that's the one that would be insoluble. Ammonium, definitely soluble, and sodium chloride, definitely soluble. So what we see here is a precipitate forming. When we take a yellow solution and a clear solution and pour it together, we're getting a precipitate forming here. Okay, so here's everything on one sheet that shows you, these are in your book. Okay, these are the flow charts that you need to learn to be able to test whether or not these compounds are soluble or insoluble. So let's go through them. Okay, potassium chloride. Potassium chloride. Compounds that are mostly soluble. All right, look, contains calcium, it's soluble. So we're going to put an S by that. We're going to say which of these are insoluble. Sodium nitrate. Oh, it's got sodium, so that's got to be soluble. Silver sulfide. Okay, do we have any rules up here about sulfides? Okay, does the compound, we come down here, here's our rule for sulfides. So sulfides, is it one of these? Lithium, sodium, potassium, ammonium, calcium, strontium, or barium? No. So then that's got to be insoluble. So we'll circle that as insoluble. Calcium hydroxide. We have rules for hydroxides. Is it one of the ones that's always soluble? Nope. Is it calcium? Yes. So it's what we call slightly soluble. So we're going to write that right here, slightly soluble. Slightly soluble, and we'll circle it. That means it will dissolve some in water, but not all the way. So we don't really call it insoluble, but it's slightly soluble. Ammonium phosphate. Oops, I forgot to put my 4 down as a superscript, but you know what that means. Ammonium phosphate. It's got ammonium. It is always going to be soluble. Okay, barium sulfide. Here's sulfide. Does the compound also contain barium? If it does, it's soluble. So just because it's a sulfide does not mean that it's going to be insoluble. Strontium hydroxide, again, I forgot to put my 2 down, but strontium hydroxide. So here we have our rules for hydroxides. Doesn't contain there. We go here. It contains strontium, so it's going to be slightly soluble. Again, we'll write slightly. Okay, what about lead iodide? Okay, so we have compounds that contain iodide. Does the compound also contain silver, mercury, or lead? Yes, then it's insoluble. So that's an insoluble compound. Lithium carbonate, it's got lithium. It's going to be soluble. And that is what you, my friends, need to be able to do. Without having this chart, you need to know how to decide whether something's going to be soluble or insoluble. So determine whether each compound here is soluble or insoluble. I'll give you a minute to pause the video and see if you get them right. So what I want you to do is pause the video, take a minute to work through them, and then I'll restart the video so you can see the answers. Okay, so A, silver bromide, insoluble, contains bromide, but it has silver, so it's insoluble. B, calcium chloride, is soluble, contains chloride that are normally soluble, and calcium is not an exception. C, lead nitrate, contains nitrate, that's always soluble. D, lead sulfate, insoluble, became sulfite, which is sulfate, which is normally soluble, but lead is an exception. So there's another one that you can do, a skill builder in your book, and the answers are given here to make sure that you understand how to predict whether or not something is soluble or insoluble. You're expected to know this. Okay, so what I want you to do is go to page 76 and look at example 217. Okay, write it down, bring it to class. You'll wish you had if you don't. Write it down, bring it to class. Look at the end of chapter example 7.18. Write it down. It's going to be on your quiz. Okay, do the end of chapter problems 57 through 62. And the blue problems in the back of the book, check them. Write them down and bring them to class. There will be a quiz where you can use your notes. So you'll be able to use your notes if you watch this video and you do what I ask you to do here. You'll do very well on your quiz.